That's right. Is this mic hot enough? All right, cool. So I am the Director of Tools Technology at Telltale Games, and at Telltale Games we use Qt extensively, and all of our tools are kind of in our engine using C++ and a bit of QWidgets and a lot of QML. But in the process of writing our tools, we've run across quite a few conflicts with modern C++, kind of C++ 11 concepts, with getting it to work with QObjects, especially in Qt. So we're going to be discussing a few of those topics and kind of the workarounds and the ways that we've found to fix those issues, and then talk about a bit about where Qt is going and hopefully how Qt will fix this themselves. So some of our QObject Gotchas, multiple inheritance that comes up quite a bit. So you can only have one QObject in a hierarchy. So this presents some issues sometimes when you want to be able to declare signals and slots and kind of have a nice common base class or a utility class. But if you are deriving from QObject directly and you're going to try to use that common class in a widget or something like that, then you're going to run into issues because widget is already a QObject. And you can't derive from multiple QObject-based utility classes. And the other main gotcha you'll find is that templated classes don't really work with QObjects, in that if you are deriving from QObject, you cannot put the QObject macro into a templated class. That capital QObject macro is what allows the mock to package your signals and your slots. So if you can't have that, then you can't have signals and you can't have slots. So if you want to use templated classes, we're going to have to use some kind of tricky techniques to get around those limitations. So let's start with the easy stuff. If you have our scenario one is we've got multiple inheritance from two different classes that each define slots. So we'll have utility class one that's just a TCPLogger. It listens to a TCP socket, let's say, it's ready read signal, and then it defines a slot that just logs the data internally. And then the idea of this utility class is if you derive from it, then you as a child automatically get all this functionality. Similarly, just for example's sake, we'll have a text edit logger that at the same time in the same class, you want to be able to listen to a QText edit's text change signal and then log any text that is changed. And so if you want to combine these into one class, you can have issues. So let's talk about kind of the normal C++ way we deal with it and then what you might have to change. So many of you will recognize this as the dreaded diamond problem. The dreaded diamond is that occurs when you want to derive from two different classes that each have a common base class. This happens all the time in our development when we want to derive from things that each derive from QObject. So in our little diagram here, A is QObject, B and C or whatever you need to be, and then D is what you're trying to define. So we could try to solve this with virtual inheritance. What virtual inheritance does, it's kind of a more advanced C++ concept. It allows you to derive from a class, and then if you derive from multiple classes that each derive from a virtually inherited class, there will only be one copy of that original class. So in that little diamond example here, if B and C each derive virtually from A, then in D, the compiler guarantees there will be only one instance of A. So you'll only have one QObject in this case, right? So if we were trying to do this, we'll have our little TCPLogger class that you'll see there. It virtually derives from QObject. It defines its constructor. In the constructor, it connects to the socket's ready read and then to its own little slot that just does a log it hand wave thing. And then the text edit logger does basically the same thing. It also derives virtually from a QObject. This is how in C++ we often solve the dreaded diamond problem. Unfortunately, virtual inheritance doesn't work with mock. This is yet another problem that we're going to have to find a different way around. So what would we actually do? So in this particular simple case where we only needed slots, we can avoid deriving from QObject altogether and then use this new connection syntax. So the new connection syntax there's a couple new QObject connect methods. But the particular one that we're using here takes in the sender, the QObject sender as normal. It takes in the signal as normal, but then it takes in a functor. And so in this case, a functor can be a lambda, and so we'll be using that directly. Now the caveat to this is, normally when a connection, the slot object is destroyed, then the connection is automatically severed by virtue of the QObject destroyed signal. But in this case, we're connecting to a lambda, so it's not a QObject. So we're going to have to be a bit more clever about severing the connection ourselves. So we'll look at our TCPLogger class. It does the connect again. It uses the same signal and slot, but the same sender and signal, but instead of a slot, it creates a tiny little lambda that just calls this our implementation of onSocketHasData. So it's basically doing the same thing. It's just a pass-through. The tricky part is that now we have to define a destructor, and that destructor is going to explicitly sever that connection. And the other part you'll notice is that instead of ignoring the return value of QObject-connect, as so often is done, we store that in the little member variable, our logger connection, which is a QMetaObject connection. So we have to hold on to that and then make sure to sever it when we die so that the connection doesn't stick around. If the connection stuck around, then the signaler would actually still try to call to this lambda. It would get to this pointer would no longer exist, and it would explode, which we try not to do. TextEditLogger I included for completeness, but is basically doing the exact same thing. And then we can easily just derive from both of these things. No problems, no QObjects, no dreaded diamonds. So let's go over another scenario. So in our scenario 2, we've got a base class that defines the signals and slots that Descendant, which is a QWidget, needs to use, right? So let's say we're writing a NetMonitor dialog window that derives from QDialog that uses functionality from NetListenerBase, and then so you can see NetListenerBase below. It just defines signals and slots, and because it defines signals and slots, it must be a QObject. So it does pretty simple things. It defines its own signal, and then it has a member timer. It connects to the timer's timeout, and then to its own slot, that on timer tick, and then it starts the timer going. And so every 50 milliseconds then it'll be calling into that slot, and then it'll try to get information from that net connection, and then if it gets it, then it'll emit its signal saying, I've got information, and information was received. But now we're trying to define a NetMonitor dialog, a QDialog, and we'd want to derive from this, but a QDialog is a QWidget, is a QObject. So we're already running into straight problems, and we can't have two QObjects in our hierarchy. So what are we going to do about this? So what we can do is we can put the functionality in the base class, including the signals and slot functionality, but not actually define them as signals and slots until lower in the hierarchy, as in the child class. So here's the base class, but rewritten without being a QObject. So it's NetListenerBase, just as before. Now here's where it's a little bit tricky. Remember, information received was declared as a signal before in our ignorant implementation. Now we're just going to make a virtual void, pure virtual, information received with the exact same parameters. That allows us to be able to call into this function, but it is not yet defined as a signal in our base class. On timer tick, which was a slot, is no longer defined as a slot, and it does basically the exact same thing it used to do. It even calls information received with an emit call, and it does this because emit is actually compiled out to mean nothing. Emit is just kind of syntactic sugar, so that means nothing. So that's every time you're emitting a signal, you're only calling that function directly. So we can do that just as well here. Otherwise, it's exactly as the class was before. We haven't lost any functionality. We just lost the declaration of the signals and slots. And then so here's our derived class implementation. Now note, we're going to be using another connect syntax call. And so this It's just like the other one, except you'll see in the middle there, it's got a const QObject pointer context. Because we are a QObject in the derived implementation, we can use this. And so what that means is, instead of us having to maintain or to sever our own connections, we can rely on QObject, on this context object, taking out the connection when it itself is destroyed. So if we looked at the derive class implementation, it's going to derive from QDialog, because that's what we're making. It's going to derive from NetListenerBase, which is not a QObject, so we have no problems there.
Any questions?
And then in the connect call, we're going to go, instead of connecting directly to a slot, we're going to provide this as a context object, because again, by this time, since we're derived from QDialog, we are a QObject. And then we're going to do something a little bit tricky, and this is a C++ 11-ish thing. We're going to do a std bind, which is going to create us another little function. And the std bind, all it does is associating a member function with a particular object. So the particular object we care to be called is on this, and the function is that member function. So the std bind is really just giving it a context to call it, because we're no longer calling a member function directly, we're calling a functor. Otherwise, it's pretty much as you expect. So now we're going to finally define information received as a signal. And what that's doing is I could have included the override keyword after that. Either way, it is an override. So we're defining a signal section, and then we're actually declaring and defining the information received signal, which was pure virtual in our base class, which is something we're allowed to do. And then now in the protected section, this is probably unnecessary. You could get away with it, but because I wanted to std bind to our particular member function, I just did this using NetListenerBase on timer tick, and that basically just says, take the implementation that's up somewhere in my hierarchy and pull it back down into me, so it isn't masked, and it's kind of considered, it's redefined locally without me having to syntactically type it again. It's basically importing the function from a parent. Sorry, we got a lot to talk about, so I'm going to have to keep blazing through this. So we got a third scenario here. We've got a templated class that uses signals and slots. Now, we already know that's going to have problems, so this is the kind of ignorant implementation of it. So it's just a serializer. It's a template because it holds objects of type T up to 25, is arbitrary example. And then it knows how to cast that into a byte and then just slam all the T objects into a buffer. And mock forbids us from using the QObject macro, which means that we cannot declare signals and slots directly in this. So this below example won't work because it's a templated class. So we can't have the QObject macro there, we can't have the data ready signal, and we can't have the on buffer ready serialized protected slot. None of that will go. So how are we going to get around this? So when you're creating a template class, if you have the luxury of your design allowing it, you can make kind of an in-between QObject Base Class that will have pure virtual slots. So just like we had a kind of a pure virtual signal in the last example, we can do the same thing with slots. So we'll make a serializer base class that is not a template itself, derive it from QObject, declare the QObject macro, declare whatever signals we're going to use, declare whatever slots we're going to use, but we don't have to define the implementation of the slots. We can go straight into say it's an on-buffer ready serialize, and that will be defined later in our lives. And then we can do whatever functionality we care to in the base class, but in this case, we're trying to make it so the templated class defines all its own functionality. So if we look at the derived class, which actually is a template, it's my serializer. It now derives from that serializer base that we just created. The serializer base pretty much does exactly what you think it does. It's got that. So now it's got on buffer ready serialize, which we declared briefly here, as we saw, as pure virtual. So now we're giving it a substance. We're giving it an actual implementation. We use the little override keyword to make sure everything's correct and everything's present that we expect to be, and then we provide the actual slots implementation, which is still a genuine bona fide slot. It's just wasn't declared so within a template, so mock has no problems with it. Okay. Scenario 4, this is kind of our most advanced scenario. So let's say we wanted to use multiple QWidget helper classes in one hierarchy. I'm a big fan of object-oriented programming, like derivation approach, so making little helper classes that you can just derive from, and then you automatically get the functionality of those helper classes by virtue of deriving from them. So let's say we had, let's take two helper classes that we might want to do. We'll have a widget geometry helper class, and we really use this in our own tools, that derives from QWidget, and it can overwrite QWidget virtual functions that kind of can save and restore position and size of a particular window so that it's where people left it and people get kind of happy in their workspace setup. And then we have kind of a conceptually similar thing, which is a selection saver. This is for model views. If you're used to table views or tree views or list views, they each have their own selection model, and the selection model stores which particular indices are selected at any given time. And it can be helpful to maintain that, especially persistent across sessions if they have a particular selection that they're using, several meshes that they're looking at, then they want to multi-edit at the same time. It's nice to be able to save that and then have that functionality all abstracted as a little class that anyone who makes their own view can derive from. Now, each of those would be trivial to derive from and use individually, but if we want to combine them together, we've got problems. One expects to be a QWidget, and the other one expects to be an abstract item view, which also is a QWidget, and we're going to get in some diamond problems. So here's like our ignorant implementation, our GeometrySaver. It derives from QWidget. It overrides QWidget virtual functions. These are real virtual functions in QWidget. The resize event, and then it holds a QRect, which is like its size and its position, and then in the resize event, it listens to it takes the new height and width that have been passed in, and when it gets a move, then it gets a move event, and then it stores the top left, stores the position that we're talking about. So it's pretty simple, but useful. Selection saver, kind of the same idea. It expects to derive from abstract item view, and then it uses the abstract item view's selection model function you'll see there, and so in its constructor, it calls selection model and expects to be getting a selection model back that it can then connect its own slot to do its selection change stuff, which I'm not going to write all the implementation for because you can do that yourself and it's not art. But I couldn't derive from either. I can't derive from both these classes because again we have got the widget diamond problem. So our solution is kind of this somewhat obscure pattern, which is the mix-in pattern. So if we want to, let's say we want to make a tree view that uses both these classes. So like tree view is both a QWidget and an abstract item view. We're going to have problems, as we said. Okay, so the solution is the mix-in way is we can rewrite GeometrySaver and SelectionSaver as template classes. And then the magic here is that the template class, the template parameter is going to be what class it derives from. I think it's most easily seen in an example, so we'll go here. So let's say we've got the GeometrySaver. Here's our rewrite if we're making it a mix-in. Okay, so instead of deriving from QWidget, we now derive from widget base, which is a templated parameter. Okay. Otherwise, it's doing exactly what we expected, or what the last one did, including declaring resize events and move events as overrides. So if I try to create a GeometrySaver and pass it in a template parameter of int or something like that, the compiler will puke instantly and say, hey, there's no resize event in my base class that I'm overriding. That's not going to work. So this is a compiler enforced compiler enforces what classes we can derive from, and they must have a resize event and a move event. So this class can only functionally be used with a QWidget. Now, the selection saver is slightly more complicated. It's doing the same mix-in trick where it's instead of deriving from QAbstractItemView, it's deriving from view base, which is just our templated parameter that we're passing in. We can no longer have the QObject macro because again we're a template, so this is where it gets a little bit tricky. And then so if we're we can still call that selection model. So let's look at our constructor here. We're doing a connect to our selection model, which will only compile properly if there's a selection model defined, which is kind of our duck template pattern. And that's always provided in QAbstractItemView, which is kind of a way to enforce that this is going to be derived from the correct class. So then it connects it, but we can no longer define our slot directly. So we're going to have to go back to kind of what we did in the first example of giving a context object as our this, and then just a quick little lambda that just does a little pass through of the selection changed signals, selected and deselected item selections, and then it just passes that right on through to the on selection changed, which again, we couldn't be a slot even if we wanted to because we're writing a template mix-in. So now declaring our actual tree view is just a chain of these template classes, okay? So our mix-in tree view is a selection saver, which is a GeometrySaver, which is a tree view. So if we look at it in code, we have our class mixed in tree view, and we derive publicly from a selection saver, which in turn derives from GeometrySaver, which in turn derives from QTreeView. And that satisfies the each chain. So if we look at that from inside out, we've got a tree view, which satisfies the GeometrySaver's requirements for I can only save geometry of a Q widget. I expect to be a Q widget by the time I get to be me. And it is getting all that functionality from its parent, the QTreeView, so we're fine there. And then we take that whole conglomerate GeometrySaver tree view, and then we go back into a selection saver. And selection saver now has two items up in its hierarchy, that QTreeView. And a QTreeView is a QAbstractItemView, so we're satisfying its requirement of having to have a selection model function that will return a valid selection model and allow us to save that off and listen to signals regarding things being selected and unselected. So that's the tricky bit. So now the question is, it's great that we've got these acrobatics and things we can do to work around problems, but is this going to change? Do we have to do this forever? And the answer is, I hope not. This presentation and all presentations is going to be on the web, so you can follow all these links, but these are just links and kind of brief discussions of what has been going on in the dev mailing list recently in the last couple of years. So Thiago, who's QtCore's maintainer, talks about how it's trickier than you'd think it might be to allow templated signals, templated classes, and basically templated QObjects into the current mock architecture, and there's a link to that. And then that being said, Olivier actually did submit a patch to Qt that would allow mock to process templated classes. There's a giant thread on that that I've linked here. Unfortunately, the patch was rejected by Thiago, and as linguists, due to this implementation kind of requiring mocked files to be installed, so there's a lot of private implementations that would suddenly have to be public and installed on the compiled machine, which isn't necessarily where it should all be. So that can work, and you can actually roll it into your own Qt if you compile your own Qt as we do, but it's not going to make it into the mainline anytime soon. Some people want to do away with mock altogether, and there's a fork of Qt called CopperSpice. It's a pretty benign fork. They seem to want to help more than hurt, and we can always adopt it back in. But their goal is to remove mock altogether, and when they did, they managed to make it so that they can support templated classes directly with their signals and slot paradigm. I don't recommend moving to CopperSpice. We certainly didn't, but it's interesting ideas nonetheless. And then in a big thread titled Is Mock Obsolete?, which is kind of an inflammatory title, but it's a good discussion. Thiago and others discuss why we might need to wait for C++ reflection, actual language support, which is coming in C++ 2020, which will allow us to kind of do genuine templated QObjects. Who knows if we'll get there, but at least we have these techniques in the meantime. I guess we're kind of out of time for questions.
Yeah, unfortunately, we're coming to the end of this session, but we're going to be having drinks starting at 6:15. So if you have any questions for Alexander, then feel free to ask him over a drink or a beer.
Yeah, I'll be there, and I'll be at the back of the room. I'll probably skip the next session, so if anyone wants to catch me for a question, I'll be here.
Great. Thank you
All right,
for everyone
thanks a
for
lot.
attending.